Don't worry. We will just discuss now. Finally, we will just discuss your question paper. What you have done.
Okay.
I've sent you the answer script. You just check them. So, what was your first question? Let's start from set one. Can you all see this? Can you all see?
Yes, sir.
Okay. So, what was your first question? Who got 3 particle two box? Your one question was there were, I think, how many? 2 particles.
2 particles, sir.
2
Set
particles.
one.
4 box. 4 cells.
Yes, sir. 4 cell.
Clear? So suppose initially the first question was what was the probability of particle being one of the particle being in one of the cell. So first what you do is if you only have a single particle, okay, let's consider only a single particle. Many of you have done it. If you only have a single particle and there are how many? 4 compartments. So either particle could be here, 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 here. So the number of microstate will be what? 4. If you only have a single particle. Clear? Now second question was total number of microstate and total number of macrostate. Total number of microstate is given by what? Total number of microstate is given by how many cells do you have? Because I think we have done this. Do you remember when the compartment was not equally spaced? We break them into a cell. So basically what do you do? Number of cells divided by to the power number of particles. So it will be 4 times 4, 16. Clear? This is how you usually do. Previously you had how many? 2 compartment, n number of particles. So you have 2 to the power n. So here you have 4 compartment to the power 2, 16. Now manually also you can check it. First now let's find the macrostate. Clear? Now your first macrostate will be what? This is compartment 1. Let's call this as macrostate. Macrostate. And this as box 1 and cell 2. Sorry. First macrostate is 2 particle 4 box. So where the particle could be? 4 compartment. 2 particles could be over here. So it will be how much? 2, 0, 0, 0. Clear? 2, 0, 0, 0. So what is the in what? 2, sorry, 3 and your 4th compartment, and here you have total number of microstate. Total number of microstate in given. So how many particles is over here? 2 particles. And over here 0, 0, 0. So number of microstate is how much? 1. Clear? Is it clear?
Yes, sir.
Now similarly another possibility is 0, 2, 0, 0. So it will be 0, 2, 0, 0. The number of microstate is 1. Now we will continue this. So third is 0, 0, 2, 0. Again 1. Just decrease the size. Is it visible?
Yes,
So
sir.
third is 0, 0, 0, 2. Again, one microstate. For which macrostate? 0, 0, 2, 0. So it will be 0, 0, 0, 2. Now actually it is what? Distinguishable particles. So 2 will be what? This 2 will be AB. A and B. If you remember. Do you remember?
Yes, sir.
Now what will be another?
One
Good.
1000. 1100.
1, 1, 0, 0. So
110.
it will be AB 0, 0. But for the corresponding, you can also have BA. Yes or no?
Yes.
So
Yes,
the number
sir.
of microstate for this one is how much? 2. Clear? Similarly,
sir.
what is the other arrangement can we have? 1, 0, 1, 0. 1, 0.
110.
So it could be either A over here 0, B over here 0, or B over here 0, A over here 0. So again similarly 2. Clear? This is how you find all the remaining macrostate and microstate corresponding. So what you people have done is, Ritika, you check this. What you have done is, I think you have reused this formula, n factorial divided by n factorial, n minus n factorial. Do you remember? Ritika?
Yes, sir.
But what this gives you is number of distribution in a macrostate. Clear? Let's say, suppose you have this distribution. Clear? So what is the total number of particle over here for this distribution? N is or constant 2. So how many do we want? One particle. 1 factorial.
I didn't get it.
2 minus 1 factorial will give you what? 2 factorial divided by 1 factorial, which is what? 2. Can you see there are 2 number of microstate for this given macrostate? Can you see?
Yes, sir. Yes, sir. Yes, sir.
So this gives
So
you the
it's
number
like,
of yeah.
hello? It's also
Yeah,
like to find a particular microstate for like एउटा microstate को लागि like particularly find गर्न like
Yeah, because the probability, do you remember how the probability is defined?
no sorry. So you n
Probability.
factorial
Yeah, this was basically your what? Thermodynamic probability, or what? Simply n factorial divided by n into n minus 1 factorial. Then the probability to the power n q n minus n. It was something like this. No, it was n and n minus n, if you remember. Now,
Yes, sir.
for this setup, you have to put it over here. The probability of finding a particle in this macrostate will be the quotient. So that's why you use this number of microstate. Clear?
Yes, sir.
Because this is not, you are not finding the total probability. Now the probability to find the particle in this macrostate. So the distribution of that microstate or number of microstate will be given by this. Clear? So as we keep on continuing, what are the other possible? Again, another possibility is 1, 0, 0, 1. Clear? Again, this will again have how many? 2 number of microstates. Clear? Apart from that, it will be what? Apart from that, it will be 0, 1, 1, 0. Again, this will have how many? 2. Because, and again after that, what you can have? 1, 0, 1. So again, this will have how many? 2. And apart from this, 0, 0, 1, 1. This is also a possibility. This will also have how many? 2 number of microstate. Now that's it. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of macrostate was how much? Total number of macrostate was
10.
10. Now total number of microstate was 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. Total number of microstate was how much? 16, which is exactly given by 4 to the power 2. 4 into 4. Clear?
How did you count like 2, 4, 8, 6, 6 in there?
2 plus 2, 4. You added all of this. All of this microstate you have to add, no?
Yes, sir.
Is it clear? So that's why I'm saying, now if you can find this distribution for each and every macrostate, and if you add it, that will give you total number of microstate. Is it clear now?
Yes, sir.
Now, can you see where were your mistakes?
Yes, sir.
Now, the third question was the probability of particle being in any of the one of the cell. Clear? Now, for particle being in any of one of the cell, this is also probable. Can you see? This is also probable. This macrostate is also probable. This is also probable. This is also probable. This is also probable. This is also probable. Can you see why? Because there is only one particle in one of the cell. So that was the question. Clear? Understood? Yes or no?
Yes, sir.
So what you do? To find the probability, what do you do? How many total number of how many macrostates are here?
10.
1, 2, 3, 4, 5, 6. 6. Favorable. Total number of microstates for that favorable is how many? This much. Favorable event is. Which is favorable microstate is 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6, 6 to the 12. And total number of microstate is 16. So the probability of particle being in any one of the boxes is basically how much? 12 by 16. 4 3 is 12, 4 over 16 is basically 3/4. Clear? Is it clear?
Yes, sir.
Now also you can do this in this manner also. Do you remember the probability where we have done mutually exclusive, those kind of thing? Or now the probability of whatever I have asked you is either the particle could be in this macrostate or 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 this macrostate, sorry. Isn't it? Yes or no? Because this is also possible. So, or a particle
Yes,
could be in this macrostate, that is also favorable. So what do? You sum up all the probability relating to that. So for the first one, it's what? 2 divided by total number of microstate is 16 plus 2 divided by 16 for another one. But how many do we have? 1, 2, 3, 4, 5, 6. 2 by 16, 2 by 16, 2 by 16. 1, 2, 3, 4, 5, 6. Now if you add all of this, how much you will get? 6 times 2 by 16. 2 8s are 16, 2 4s are 8, 2 3s are 6. Exactly 3 by 4, whatever you were getting previously. Clear? So you can do this in either any of the way. Now what was your third question? What was your third question? Probability of all the particle being in one of the box. 2 particle being in one of the box or 3 particle.
So I add 2.
Okay, the probability of 2 particles.
3, sir. 3, sir.
If it's 3, then the probability is 0. Because there is no such distribution, because you have only 2 particles. Is that kind of macrostate possible? No, because there is only 2 particles. Clear? Now the question, if there was probability of being 2 particle being in either one of the cell, then what do you do again? You again add this 1, 2, 3, 4. 4. The number of microstate over there is 1, 2, 3, 4. 4 divided by 16. 2 8s are 16. 1/4 basically. Clear? 2 particles being in one of the box. Now, if you add total probability, now this was particle being in one of the box and this was particle being in what? All the particle being in one of the box. How much you'll get? 4/4, which is basically 1. Can you see your total probability is also conserved? Is it clear?
Yes, sir.
Now, what was the another question? I think that's it. 4 question. And similarly,
Yes, sir.
for who got 2 particles, 3 box.
I got, sir.
2 particles.
Yes, sir. I got two
In-
particle, 4 box.
3 particles. I think 3 particles,
सुने कि भाई मैं
2 box. I think Mingma and all got this one. Nehal, I believe you got this question. 3 particles, 2 box. Just now we have done 2 particles, 3 box. Now what do? Now total number of microstate is given by what? 2 to the power 3, 8. Clear? So what are the possibility of the macrostate? One is obvious. 3 particles over here, no particle on another box. Corresponding 0, 3. This is here macrostate. And corresponding microstate will be what? There will be only one microstate. For this one also only one. And what about this third one? 1 particle could be here and 3 particle could be here. Now for this it will be slightly different. I will tell you why. Why it will be different? Because over here, what is the possibility of this particle being in 2 of the box? 1 could be here, A, B, C, D could be here. Clear? B could be
And we have
here.
only 3 particles,
A,
sir.
C, D. Yeah?
We have only 3 particles, sir.
Sorry, 1 and 2. Is it clear now? A, B, C could be here. Second is B, A, C could be here. Apart from that, C, A, B could be here. So total number of microstate will be 3. That you can find it readily. Clear? How do you find that? That same formula, n factorial divided by n factorial, n minus n factorial. You do it for the left one, but it's same. It will give you the same result. Number of particles were 3, and you are choosing 1. This is 2 factorial. So this will be how much? 3 factorial divided by 2 factorial is how much? 3 into 2 factorial divided by 2 factorial, basically 3. Exactly, did you get 3?
Yes, sir.
Now suppose, now if you want to check, both the probability will be same. Now if you want to check for this second 2, both will give you exactly the same. Why? I will show you. 3 factorial divided by, this will be 2 factorial. 3 minus 2 factorial will again give you how much? 3 factorial divided by 2 factorial, again 3. Both of the distribution will give you the same number of microstate. Is it clear?
Yes, sir.
So 2, 1 will also exactly give you 3. And apart from this, what are the other distribution which is possible? That's it, I believe.
Yes, sir.
So total number of microstate will be how much? 8. Total number of macrostate will be 4. Clear?
Yes, sir.
Which you got exactly over here. Now the second question is one of the particle being in, probability of particle being in one of the box. One of the
So
particles.
which is the most favorable microstate, sir?
All the microstates are equally favorable. Understood? Only the macrostate are not equally favorable. All the microstates are equally favorable.
Okay.
Why? I will tell you. Because what is the probability of a single particle being in any of the box? Because it doesn't matter, A, B or C, all will have equal probability of being in any of the box. Do you remember postulates of probability? Basic postulates of probability. All the microstates are equally favorable. So that is how we used to do. Do you remember? So the probability of a particle being in what? One of the microstate is what? Over here. 1/2 over here, single particle. That is here probability of a particle being in one of the microstate. Clear? All the microstate will have this probability because there are two boxes. There are two cells. And each particle will have how many? 1/2. What number of compartment? Clear?
Yes, sir.
Is it clear or not? Now, if it was 4 box, then the probability of being in one of the will be what? It will be 1/4. 1/4 over here, 1/4 over here, 1/4. Now, can you see each microstates are equally favorable? That is what I wanted to say. Clear?
Yes, sir.
No, but the macrostate are not equally favorable because if you check, these two macrostate are more favorable as compared to these two. Can you see? Because this has only one microstate and this has how many? 3 microstate each. These two are equally probable. Understood? So that's why a probability, if you plot probability or you plot number of microstate versus versus certain number, then we used to get this kind of distribution. Do you remember this kind of thing? Do you remember? If you plot probability versus do you remember for binomial distribution, these two in between are as most highest probability, then those are most favorable macrostate, most favorable
Yes, sir.
macrostate, but all the microstates are equally favorable. Now let's move on to your second question. So what was your question? One particle, probability of one of the particle being in.
Three particles.
So you,
Three particle being
3 particle being in one of the box.
one cell.
Then this is basically this 2. It could be 3, 0 or 0, 3. So total number of microstate is how much? Total number of microstate is how much? For this to set up
8.
1 plus 1. For this favorable event 2. The total number of event is 8. So it will be 2 by 8, 1/4. Is it clear? Is it clear or not?
No, sir.
So it's not.
So favorable, sir, favorable microstate by total number of microstate, no, sir?
I know. I'm not talking about the most favorable. What I'm doing is the probability of 3 particle being in one of the cell. That question I'm doing.
Yes, sir. 3 particle. Sir, अगर 2 particle भएको भए चाहिँ हामीले त्यो मुनिको दुईटा लिनु पर्थ्यो सर.
Yeah, for 2 particle you have to take this one. Clear? So if the question was the probability of not finding a particle in the cell, even then you have to use this because there is 0, 0 sitting over here. Can you see? Over here and over here.
Yes, sir.
So it's basically 1/4 probability of all the particle being in one of the cells. Is it clear now?
Yes, sir.
Okay. The probability is 1/4. Now, for one particle being in one of the cell, the probability will be how much? Basically 6 by 8. Now, if you add this 2, you will exactly get the total number of probability. 3 by 4 plus 1 for this one. Yeah. Now, if you check this, now this macrostate is more favorable because it is having higher probability as compared to this one. So this macrostate is more favorable. Macrostate is which macrostate? 1, 2 or 2, 1 is most favorable macrostate. And apart from this, one particle is basically this 3, 4. Clear? Now those were the questions. Now apart from that, what was the other question? The other question was, for a given molecule, for a given particle or anything, that your degrees of freedom was given. Your degrees of freedom in momentum, in suppose let's say in your position, degrees of freedom in a position was given what? Position space was given 8 or 4?
8.
8, okay. Their degrees of freedom in a momentum space was given how much? Same. In each I have written. So you have to find degrees of freedom in phase space. So it's basically what? 8 plus 8, 16, or basically 2 times of degrees of freedom. What you have done? 16. That's it. Clear?
Yes, sir.
So you have a 16. So the dimension of your phase space will be 16. Clear? Instead of being 3-dimensional, it will be how much? It will be 16.
Yes,
Is it
sir.
clear?
Yes, sir.
So please don't make the same mistakes again.
Okay, sir.
So I'm going to stop.